The kind of research I'm interested in is a technique called diffusion MRI. And this technique is sensitive to the microstructure of the tissue. So in a normal MRI scan, you get basically anatomical information, and the resolution of a normal MRI scan is about, for a clinical scan, for example, it's probably about 1 millimeter. For a preclinical scanner, it's probably on the order of 100 microns, something in those lines. So the Icon is actually quite a useful machine because at the moment we have it placed along with our nuclear imaging techniques, so our PET scanners and our SPECT scanner. For the Icon, we just wheeled it in to the lab and it just sat there quite happily. 3 years ago, our 9.40 was being used the whole time, nearly 24 hours a day, 7 days a week. And there were many studies that we couldn't do because it was so busy, that the availability was so low. So what we did was to look for alternatives. And the Icon seemed like something that is viable. You don't need a 9.4T scanner for every single study. Sometimes it's a bit overkill. So we thought, well, if you get a lower field scanner, then this would be a very nice way to get around the studies that don't require such a high field scanner. As well as taking the workload off the 9.40, we've actually found that it is better in some respects. For example, looking at the contrast in brain tumours. And we've had to use exogenous contrast agents for our 9.40, whereas in the 1T we could scan it without injecting a separate contrast agent. So obviously this is preferable. Other advantages are that it's actually closer to clinical field strength. So we've had studies saying, oh, we don't want to use the 9.40, but we want to use the 1T because it's closer to clinical field strengths, and therefore research will be more translatable. I think the growth area potentially is for preclinical MRI to put these scanners into many different types of labs. So it's really quite an opportunity to grow the MRI community.